Hi everyone, welcome to the new video. This video is going to be about a Python package called Polars. So if you're a data scientist or a data analyst, or in general you work with data, you probably use and love Pandas. It has great functionalities. It's very easy to use. Can be quite fast on smaller data sets. But unfortunately, the main disadvantage that it has is that it doesn't perform that well on larger data sets. So whenever the data becomes larger than your RAM or even larger than a few gigabytes, I personally noticed that the speed drops significantly and it becomes impossible to work with it unless you have a really chunky machine, which costs a lot of money, which we don't usually have. And here comes Polars. Polars is a Rust-based library, so it was developed in Rust, but it has a wrapper in Python and also R. It has great functionality. It works with DataFrame the same way that Pandas does. Well, actually the way is very different, but the syntaxes looks kind of the same. The goal of this video is to give you a comprehensive introduction, not to learn everything there is to know about Polars, but just to give you a feel about how amazing this library is, just to see some of these incredible speedups that you can achieve, and to give you confidence to continue your learning journey. I'm going to be releasing at least 3 videos on Polars and let's see how they do. So if you like it, thumbs up and let's begin. First things first, let's go to my GitHub page. It's called aggregates and then /tutorials, and we can copy paste this link and let's just pull it. So I already have it. As you can see, if I go to code, there is a folder tutorials. So we can cd to tutorials. If you don't have it, then you can do git clone, right? And then just copy paste it here. But I already have it. So let me quickly go to cd tutorials and let me just, pull latest version, already up to date. So yeah, looks good. So the next step is to go into your VS Code, open the Polars folder and to find the basics notebook. As you can see, I have some additional stuff here. Ignore it for now. The only thing important here is this YouTube folder because it contains all the data for this project, and you can find it in Kaggle. If Kaggle, not this one, but Kaggle. It's called Trending YouTube Video Statistics. So download it and then put it inside of the YouTube folder, just like I did. And now let's go back to the VS Code. The goal of this notebook is to compare syntaxes between Pandas and Polars. And we are going to look into some of the basic methods for exploratory data analysis, such as printing out shapes, looking at columns, looking at number of rows, and describing some of the statistics for the features. Then we're going to look into the data quality. So how many values are missing? Are there any constant columns? Then we're going to move to data preprocessing. So there are going to be some things that we would want to change in this data set. For example, transforming dates from strings into the datetime objects and other things you'll see later. Then we'll move to the univariate analysis. So looking at one variable at a time and seeing how this can be performed in Polars. And afterwards, we'll jump into a multivariate analysis, which is much more interesting because we're looking at 2 columns, we're making some group bys, we're looking at maybe comparisons or trends. Going to be very interesting to see which videos are actually trending. Might help me as well to get on top of this website. Let's start from the beginning and walk through this notebook from the first line. My environment already has everything installed, so if you don't have it, just do pip install Polars. Should be quite easy. So install Polars, and then the version of the Polars that I have, let's actually see, maybe there is a new version now. Yeah, there's always a new version of Polars. It's a dataset, it's a package in very active development, so lots of new cool things are happening every day basically. So yeah, keep up with it on their website. And let's check the version. Yeah, it's 18.8. Oh no, I need to restart the kernel and to import it again. Perfect, 18.15. So, before starting to work with Polars, I highly recommend setting these parameters. So these are the global config parameters that you can set. There's a lot of them. I'm setting the one for the width of the tables. so when you print them out, they look nice, they don't get too truncated. You can see all of the parameters that you can adjust if you just Google polars config. It's going to be a lot of things here. I already clicked it. So yeah, you can format a lot of different things. You can format the formatting of the floats, you can format the size of the table, length, width, whatever you want. Yeah, it's all there, so check it out. In this project, I just changed the width of the table to 200 characters. So let's define the path variable. It's going to be YouTube Great Britain videos. If you want to do the analysis on other countries, it's very easy, just substitute it here. So the first things first to know about polars is that reading the data is super simple. The same syntaxes as in Pandas. PL reads CSV, and then PD that reads CSV. And as you can see here, even as we run, the speed of reading and writing out data is going to be incredibly faster than with Pandas. And that's the first advantage that I saw when working with polars, is just the general speed of reading and writing data. So almost 3 times speed up just because you used other library. Looks very cool, no? So now let's do common exploration of the data set. You know, we just imported it, so we just want to take a sneak peek at how it looks like. So, you know, for example, the shape, this is going to be for this is going to be for Pandas, and exactly the same attributes are used for polars as well, right? So let's just comment it out, and yeah, it even looks the same. So in this case, again, the syntax is very simple and very similar. And printing out the head, the tail, and the sample also looks nice, looks very easy to digest. It doesn't render them the same way that Pandas does, but we can actually change it quite easily. So as you can see with Pandas, you get this nice tables that you can scroll, and by default, when you print out a polars data frame, it uses a library called tabulate. So if you want to change how it gets displayed, similar as to Pandas, just do a display instead of print, and this should print it out like this. So whatever you prefer. We looked at our data, we know what it has, we know how it looks like. We can also, one thing that I usually do is just looking at the columns that we have here. So let's look at the DFPL columns, again, similar syntaxes. But for now, let's say that we want to select the columns of a specific type. So in Pandas, this is done quite easily using select D types, as you can see here. With polars, you have this select method. And then you need to specify that you want to select the numeric ones. So here you can see that it's actually cs.numeric. So what is cs? Let's go up to my imports, and it is a utility that polars offers. It's called selectors. So polars.selectors as cs. So we're using this to specify what type of data do we want to get. And here we can see that this is a numeric and string. And again, magically, it is so much faster than Pandas. Just look at it. Pandas takes roughly 3.5 milliseconds, and polars takes less than 1 millisecond. It is honestly incredible speed up just for free. So let's print out the numeric data head. This is how it looks like. So now we can see, okay, we have some sort of a category ID into which the video falls. And then we have a number of views, likes, dislikes, and comments. And then when we look at the categorical features, we can see that the trending date is read in as a string, for example. We can see video ID and all sorts of different things. So times, descriptions, names, etc., etc. So yeah, very easy to use again, especially this column selector became available just recently. So it's quite new type of syntaxes. Before that, you would need to do some sort of additional filtering using some sort of list comprehensions, but now it's super easy. So that's again a large advantage of polars, is that it gets constantly developed. The developers see what it's missing, and then they keep adding it one by one, which is really amazing. So now let's say that we want to select some specific columns. We saw, oh, okay, so we have the likes, views, and comments. Now, how would we actually select it here? Again, the syntaxes could be very simple to Pandas. So for example, with Pandas, right, as you can see here, df_pd, we just select it using a list like this, and then this is our subset. With polars, you can do this many ways. One of them, you could literally recreate it like this. Let's actually do it quickly do it like this. Let's copy paste this, and I'm just going to substitute it with PL. Sorry, indentation is wrong. There we go, and it just selected like this. Again, syntax is similar to Pandas, but it's not the most, I would say like it's not the most polars way of doing it. So the way that polars work is that it uses all of these methods that you apply to the data frames. So I don't recommend working the similar way that you do with Pandas, but instead get used to all of these methods. So for example, to select a column, you need to use a select method. Similar to SQL syntaxes, for example, right? You would do a select and then you would list your columns. The same way works polars. So I recommend getting used to it because you'll be working a lot with pl.call methods anyways. So why not get used to it now? So okay, we can select the columns, but how do we select and filter rows? As you could guess, we're going to be using the filter method. So we use for selection, we use select method. For filtering, we use filter. Very logical and very nice API. So for example, here, what we could do pl.filter, and then we can specify, okay, which column do we want to use as a filter, and then specify some sort of a condition. Sorry about that. So let's do it like this, and it turns out that 6 videos inside of the trending had less than 1,000 views, which is interesting. What type of videos are those? But yeah, I hope that's going to be one of mine. But for now, so this is the syntaxes for Pandas, how it would work here. I'm not actually sure which one is faster. Maybe we can check it out real quick. So, and this is not the most robust way of checking which one is faster, but it works for me. Quick and dirty. Yeah, so again, polars wins, not such a huge difference this time, but still, nonetheless, looks very nice. Oops. Yeah, and this difference is consistent. So as you can see here, now we need to use PL call views, because if you delete this, I don't think it's going to work, right? Because you're comparing a string to an integer, so it doesn't know that this is a column. So here you need to specify that this is a column. But here, for example, it could work if you just specified likes like this. But why would you do this, you know? If you can do it right, do it right. Okay, so let's go to the next data quality checks. So the data quality checks, what we want to usually do after we've read in the data, we checked some columns, maybe like pre-selected some columns that we are interested in, you want to do some preliminary quality checks about, for example, number of missing values. You want to select how many unique values are there, so is it a static column or not. And for this, Pandas has a superb API, I have to say. Just isNA.sum, or yeah, and then you just filter using missing or unique again, and then just compare it to the static, you know, is it equal to 1? Very easy to do. So what do we do with polars? Polars is a bit trickier in this case. We'll need to do some, first of all, calculations, and then we'll need to do some sort of filtering. So kind of doing everything that was abstracted away in Pandas manually. So luckily for us, it's not that hard. So you can see here what we are doing, we are selecting, you're already familiar with this method. We are selecting PL all, and then we're checking is null, and then we're summing it up. So what it's doing is selecting number of missing values in all of the columns. Lots of new things here, right? PL all, this is just a shorthand for operating on all of the columns so that you don't need to type them out one by one. Is null makes sense. It is the version of NA, but we call it is null. And then we do a sum of it. So if you want to see how it looks like this. It returns to you one row with number of missing values. So you can see here, no missing values, very nice. So how do we filter it out? Because it is a bit tricky to filter by column, because we want to be filtering by row usually, right? So how to do that? Well, it's actually quite easy. What we do, we add a melt method, and we call a value name, we call it missing. So all of these values are going to go into the missing column, and it's going to look like this. Much better, right? Very it looks very similar to how we would get isNA.sum. So it looks like this. Instead, we need to do a bit more stuff here. So in here we have, we can now finally do a filtering. So let's copy paste this here. And as you can see, no missing values. Perfect. So this is what it is here. And the same thing is happening here. But instead of isNull, we are applying again pl.all and then number of unique, similar syntaxes to Pandas. And melting and filtering all the same. So yeah, that looks nice. And it also works magically much faster. Look at it. It takes 46 milliseconds, almost 47. Here it looks 10, almost 5-fold increase. So I think it's worth a bit of a more verbose method to achieve such a speed up. So now that we are done with looking into data and just doing some basic checks, let's go more in depth into operations on columns, and more specifically how to do a data cleaning in polars. One of the first things that should be done is to transform the dates from strings into the actual datetime objects. So in Python we have this method called toDateTime, and in polars we have also toDateTime, or we have also toDate, so whatever you want. But the key difference here is that when we do toDate or toDateTime, we need to work within the string namespace. So you access it like this. And also key thing here is that when we do operation on columns in Pandas, we essentially select this column and then reassign it back to the original data frame. With polars, it doesn't really work this way. So with polars, we need to use this with columns clause. Those of you who are familiar with PySpark might recognize it. So essentially, you're taking the original data frame and you're doing something with its columns. All of the columns that you have, they remain, but then you want to do some operations on them. And you have a choice either to reassign them to the old names, or you can assign them to new columns, to new names, and this would increase the column count in your data frame. So in this case, I'm not assigning the columns to any new names. So I'm not doing stuff like new column like this, or there is also another way of doing it with a method called alias. So like this, you know, and then I would say new column. So I'm not doing any of that. So let's remove it. And instead, I'm not providing any name, and this means that I want to reassign them back to the old names, trending date and publish time. So let's run these two together, and we can see that the execution time is about the same. So not everywhere polars is more efficient. The next thing we should pre-process is to map the category ID from a number, as we saw it here, right? This is an integer, to a string, so the actual name of the category that it belongs to. These are stored inside of these JSON files here. So you can see ID, for example, and then the name of this category. And let's read it in and let's map it to a dictionary in a format that looks like this. As you can see, the original JSON is a bit more complicated. So this for loop here just takes care of that and maps the integer to an actual name. And let's go here and let's map it. So for Pandas, we use a method called map, and similar in polars, we use map, but now we want to map a dictionary. The method map only works with functions, so be careful with that. So let's work it like this, and again, you can see that the application time is about the same, so no big improvements here. Now we're done with pre-processing, and let's move on to the actual analysis. So the first things first, univariate analysis, the simplest form of analysis we can do, and this is just looking at how different features are distributed, what are potential values that they can take, and noticing any interesting, I don't know, anomalies, or maybe you just want to get a feel for the data. So one of the most common methods that I use, I guess you use as well, especially for categorical features, it's called value count, and lucky for us, polars also has it. The only thing you need to remember is to specify if you want to recreate the behavior of Pandas value counts, you need to specify sort equals true. So here I'm counting how many times each category appears, and then I'm plotting them in a bar plot. So one thing that I'm doing here is I'm transforming my polars values into NumPy, and I'm doing this because some of the plotting libraries are not that familiar with polars yet. so they might not know how to deal with it. Here's my plot. As we can see, music, entertainment, and blogs are the most popular 3 categories, and music and entertainment are well above the average number of counts. So yeah, not good, doesn't look good for me. I guess my videos are not getting into trending anytime soon, unless I make a music video. Another method that you can use to analyze especially numerical columns is called describe. So those of you who use Pandas know this method. Gives you mean, median, standard deviation, interquartile ranges, and all sorts of things. So it's exactly what it does with polars as well. So again, selecting this column and then describing. And yeah, you can see it here, and looks similar to an output that you would get from Pandas. Then let's say that we wanted to plot the views, and the views here are distributed exponentially, so it might not be such a good idea. Plot them in the raw format. So let's actually just take a log out of it, and you can see here the syntax is very similar to how you would do this in Pandas. So there is always 2 ways of doing it, Polar's way or Pandas way. So yeah, this is also an option. You can just select a column, and you can also just do a log, and you can not transform it to NumPy. But sometimes it will fail with some libraries, so be careful with that. But in this case, it does work, and it looks nice. So yeah, this is log views distribution in trending. That's lots of views. Now let's move on to a more complicated form of the analysis, which is called multivariate. So in multivariate, we are interested in taking 2 columns and maybe grouping our data according to one column, and then calculating some statistics for another one. So in this case, I want to group my data according to the category, and then I want to see what are the median views in each category. So which of these categories tends to get the largest number of views in the trending data set. So we have it here. It's actually not nicely formatted, so let me do it like this, and let's print it out. So we can see that music, shows, and comedy get most views, which is not surprising. So music is video clips, shows and comedy, late night shows, film and animation, all the cool things, they get a lot of views, which is expected. Now let's visualize it using box plot. So in the box plot here, I just again need to provide the category ID as my X variable, and then log number of views as Y variable. And let's see how it looks like. So yeah, as we expected, music comes up on top, then everything else is kind of distributed below that. So yeah, very interesting, and works quite nicely with polars. Now let's move on to a channel level analysis. So what type of channels do we have, and specifically which of the channels are most frequent in the trending? So we can see here that the Tonight Show, Alan Show, Jimmy Kimmel, Saturday Night Live, and then WWE. Very interesting selection. Mostly these are late night shows that are appearing in the trendings, which makes sense. They're quite popular. They're very digestible, and I think YouTube went through some period where they heavily pushed it. So yeah, now it's a default platform for this type of videos. So yeah, it's interesting to see that it gets confirmed here. So now let's group our data by channel, right? So again, the FPL.groupby, as you saw it already above, I think here, right? So you do the group by. Let me explain you syntaxes a bit. So you group by a column, and then in the aggregates, so .ag, you need to provide, first of all, name of your column, and then you need to provide what type of aggregation you want to do to it. So let's go a bit up, because I think I skimmed through it. And here we can see that I'm selecting the views, and I'm doing a median. I'm giving it alias, so this is like a new name for my column. So this is how you would do aggregation, and then you would get a new column with a statistic that you want. So interestingly, what we can do here as well, which is very cool, I think I showed a bit later, but let's do it here as well. So I can also then select, like maybe again views, but now I want to do a mean. And as you can see, all I need to do is just to provide comma, and then all of them are going to work together. So mean views, perfect. And there we have it. So second column appears, mean views. Yeah, looks good, and the syntaxes looks very clean. Really like it. I think Pandas has something similar with agg and groupby, so again, shouldn't be that unfamiliar to you. Yeah, but what I'm doing here, I'm actually just doing a count, so number of times that something happens, and that's why I'm just doing trending counts and sorting it. So we can see here that, yeah, Tonight Show starring Jimmy Kimmel, I think, no, Jimmy Fallon, sorry, and then Jimmy Kimmel appears down there. Yeah, very interesting. So who is the most frequent channel, I'm asking myself, and we can see that, yeah, that's exactly the same. So basically here, just two ways of achieving the same type of behavior. Yeah, value counts is the nice shorthand. So I would recommend using this one unless you need specific reason, unless you have a specific reason to use this more manual approach. So yeah, now let's move on to more complicated aggregates. As I said, in the group by, you can do all sorts of different aggregations. So PL count, like we did above, but then also let's count the number of unique trending videos, because a video can appear multiple times in the dataset depending on the date. So if the video held up in trending, let's say 5 days, it's going to have 5 appearances, which is going to disproportionately boost number of counts. So yeah, we want to count the uniques. Here we also want to get the total number of views, likes, comments, and then calculate the average number of views, likes, and comments as well. So lots of aggregations. Let's see how our Polars data frame performs. And yeah, that's how it looks like. So sampling 5, just 5 random rows. And you can see here that, for example, Unbox Therapy have 11 trending videos, but it actually has 1 trending video, and it just held up in trending 11 days. So yeah, that's what I was talking about before. And you can see the total number of views and yeah, the average number of views, average likes, and average comments. So next, I'm defining a function which is called make aggregates. It's very generic. I designed it in a way that it works with any data frame and any columns that you provide with it. So it might be a bit hard to understand now. So let's just see the outputs that it gives us, and then I can walk you through it step by step. So yeah, let's define it first, and this is how it looks like. So we get, as an output, we get a channel, and then we get number of trending counts, and then we get number of trending videos, and all sorts of things. So just like we did here. But what does this function actually do? Well, it's very simple. So first things first, it takes 3 arguments. df is a Polars data frame. Group by is the string that we want, name of the column that we want to aggregate by, and then the aggregate features. So these are the features for which we want to create aggregates, namely mean and the sum, as you can see here. So how it works is very simple. First of all, 2 aggregates that it does regardless of what you specify is that it counts the number of occurrences in the trending dataset. So this is here. And the second, it does count the number of unique titles, the number of unique videos per our channel. And as you can see, these aggregates live separately from everything else, right? So we define these popularity aggregates, and then what we do, we just join them together with the metrics aggregates inside of this segregation clause. So this is one of the amazing things that Polars allows you to do. It allows you to build up your aggregations and your operations and whatever you want, like selections, filters, as a constructor. So you can define them without even seeing the data frame. You can define the operations that you want to do and only pass it to the data frame at the very end, and it's going to still run it. So this is really cool, and it allows for a lot of nice flexibilities. So here we can see that we start with an empty list, and then for aggregate, in aggregate features, so let's say that I'm doing it just for one feature, let's say for views, it's going to first of all check if this column is in the data frame, so just manual check, standard stuff. But then it's going to append to this list an aggregate that calculates the sum and calculates the mean of this column. Again, like magic, right? So you build it up as a constructor. You have now these 2 lists, metrics and popularity, And what we do, then we group by our group by argument here, and then we provide these aggregates that we've built up as arguments here. It takes as an input a list of these aggregates. So, and then we get our stats, we just sort it by trending count, and we return it. Yeah, and it looks like it's working. Definitely not perfect function, so could use a lot less hard coding, and it's not actually like sure that it's required here, but I just wanted to show you how you would build a function that does all of these amazing polars operations, and wanted to showcase this kind of build up, you know, your aggregate like brick by brick functionality that polars offers. So yeah, that's our aggregate. So then we're moving on to calculating some of the ratios, which is a form of feature engineering that you could do, for example, if you wanted to build a machine learning model here, or you were just interested in some of the statistics. And what we can see here is that it is actually very simple to do. So you can just use a select method. So what it does, it actually selects this column, category ID, and then it selects another two columns and just divides them by one by another. So it divides the comment count by the total views, and then reassigns it to a new column, which is called comments views ratio. And we're plotting it, and this is how it looks like. So interestingly, non-profits and activism actually get highest comment to views ratio, followed by news and politics, which makes sense. It's very, hot topics. And then how to style, comedy. So most of the popular categories that we saw, they don't actually get that many comments when you compare them just to the number of views. So these videos you would consider as like the most engaging, and those videos like comedy shows and music videos, they are more popular. Yeah, so that's it. That's like our analysis here. We found out a few interesting things. So now let's just maybe save our kind of pre-processed data. And writing data is very simple. You just do write parquet. It took me some time to readjust from writing to parquet, as you would do in Pandas, to writing write parquet, but it's a small thing. Shouldn't really be worried about it. So that's it for today. I hope that this video gave you a good introduction into polars. In the beginning, it might feel very similar to Pandas, but the longer you work with it, the more differences you start to notice, and you just need to adjust your way of working. It's not hard, but it takes some time to adjust. From my personal experience, it took me roughly 2 weeks to become semi-comfortable with it, and 2 weeks more just to get comfortable. So this is not a steep learning curve, but it's still there nonetheless, so it might feel a bit unfamiliar. Let me know if you like this video. Don't forget to like, subscribe, comment down below. I'll make sure to be more active in replying to your comments, I promise. And I will see you in the next one.